que hayáis podido hacer relaciones, conoceros y poneros caras interesantes. Yo hoy he conocido a mucha gente que conocía por mail. Es un placer presentar ahora a Emmanuel Letouset. He's the director of, switch to English, director of Data Pop Alliance. We've been working with them for 3 years now, I think. And Richard was starting the relationship with them. And I think their approach, I just tell that this quotation that si Mahoma, you know? So Opal is about that. I just tell that. It's a very innovative concept. It's really targeting a problem we have is the ability to share data with third parties. So
or not.
or not. And Emmanuel has a lot of experience dealing with demand-side agencies and data providers in order to make them work. So,
thank you very much. All right, so thank you all for being here. So I'll try to, so my presentation has a lot of, too many slides as always, and it tries to cover a lot, so I'll try to be as efficient as possible. So I just want to first thank the organizers. It's always a pleasure to be in Madrid. I'm French, as you can hear, so I love both Zizou and Griezmann, so everybody's sort of like, happy. So thank you, Pedro, Richard, Christina, Anna, Elena. Really happy to be here. So this is indeed the topic, the title of my presentation. As you can see, it's pretty broad and ambitious. So I want to talk about big data, so in general, and put it in context. Talk also a little bit about some conceptual aspects. This concept and project of open algorithms, which I think is very interesting. Try to link it with resilience and resilient societies. What does it mean to be resilient? And also a bit of AI, here and there. So so these are like my main affiliations. So I live in New York, and I came yesterday from New York, but I work mostly at MIT and New York at Datapop. So this is the outline. So I try to stick to about 4 minutes per section. So it's going to be pretty fast, pretty surface. But hopefully there will be enough for questions and discussions afterwards. So some introductions and the main questions. Try to put these questions in context of the so-called fourth industrial revolution in particular. Then talk about the prospects and the fears, so creative destruction or destructive creation, and then try to share a vision for what could be human AI or machine human ecology, where everybody, we wouldn't be the end of the world, and then finish with open algorithms, so as a concept and as a project in at least, I hope, 6 to 7 minutes for the last part. Okay, so introduction. So first of all, so this is one of my cartoons that I did many years ago, so I use cartoons in my presentations. It's like my second half of my brain or second part of my life. So I'm not a data scientist. I'm more like a development economist, demographer. And I think that informs a lot of the way I think and talk about this field. I don't believe in technological fixes, but I'm not a cynic either. I went back. Yes, so let's say, and so also to say that there are some cartoons in the presentation, not just mine, but from the New Yorker and then that kind of stuff. So yes, speaking of the New Yorker, you may have seen this cover from a couple of weeks ago, which I think pretty brilliant. This future where we're all going to be enslaved by robots. So is it a possibility? Are we all going to be paid to do nothing because everything will be done by machines? Basic universal income kind of discussions, and I think both of those options will be pretty bad actually. So is there a way to sort of make the most of these technologies and algorithms and data to devise, design, think about a better, fairer, more resilient world? So Now in context, so it's a slide that I use a lot, and I won't go over every single of those papers. Hopefully the slides will be shared afterwards. So it's sort of like a decade of this so-called big data revolution. What is interesting is that now we talk increasingly about AI, and big data feels a bit like almost old, whereas like 4 years ago it was like the big thing. There are many commonalities between big data and AI. A lot of what is called big data is actually AI, and so like vice versa. I mean, we could discuss that. So I entered this world by working for UN Global Pulse in 2010-11, and I wrote this paper report, Big Data for Development, and since then I've focused on the applications and implications of big data for development, broadly speaking. And I was also interested in conflict, like migration. So those issues of resilience and shocks and vulnerability have always been pretty high on my in my mind, or on top of my list of interests. So one thing quickly is that I also show this slide very often. When I think or talk about big data, I don't talk only about the data, like the raw material. I talk about big data as a field. So I try to use small b, small d for the raw material, like the crumbs, and big data with small, like capital B, capital D, as the ecosystem. Like you would do the same with open data. And you would say open data is, or big data is, because you talk about the field or the ecosystem or the phenomenon. You don't talk about the data, otherwise it would be plural. Yeah, I learned also that actually I should press the other button. So speaking of learning, yeah, so I said there's a switch from big data to AI. So some of you may be very familiar with AI. Again, I said I'm not a data scientist. I mean, I've learned quite a bit over the years, but I'm not a computer scientist either by training. So I had to learn a lot of those things to also be able to translate them for non-technical audience. So in short, AI today is very data-driven. I mean, there was historically two strands of AI. The one that is most prominent is the sort of bottom-up data-driven approach, and it's based a lot on those ANNs, those artificial neural networks that try to mimic human neurons. And it's basically algorithms that learn how to automate parts of tasks, increasingly complex. And you have an input, which is here on the left, and you have an output and something in between, which is sometimes referred to as the black box. And it's partly true, partly not true. But there are, of course, problems of explainability, of course. And also, it's also what has not been invented yet, because things that we take for granted, like Google Map, that's AI. And we are used to them, and we don't necessarily think of them as AI. So we think more of AI as the next robots, or things that we, credit score, kind of, automatically you will be given a loan or not, those kinds of things. But AI is already there in many, many ways and instances of our lives. So the gist, the basic of AI, that's why it's also, people talk a lot about, and you've heard the terms, machine learning, supervised machine learning, deep learning. In short, it's about training those sort of neurons and neural networks. What is the right recipe to get a good answer? That's the gist of it, if you want to simplify. So you would ask a computer, a machine, is this a beach or is this a city? And then it would say, it would take a guess, beach, yes, and then city, no. And then over time, through iterations, the machine learns because it selects some points in the picture and then say, oh, when I do that, this helps me get the right answer. And so through these feedback loops, the machine is learning, and that's the gist of machine learning. Of course, this is very superficial, but I have 45 seconds. So, so driverless cars are based on that. So you need a lot of data to train your algorithms, your machines, to actually learn, recognize, etc. So, is it black magic? Is it new? Likewise, I have 30 seconds for this slide, so it's not new. It's AI was invented about 60 years ago. So it's not very new. In short, it's still pretty stupid. Like, you know, we're very far from like a general AI that would, you know, take over the world. So it's more like a so-called like narrow AI in some field, and humans are still in control, for better or worse, of the process. But what is new, and so like the good magic is this notion of credit assignment function. Is that those, so like, you know, what happens in the black box is that these algorithms are able to understand and to like learn what works and what doesn't work. So what are the right like recipes, or what are the neurons that need to be strengthened to get the right answers, in short. So it learns. So it's the term credit assignment function like says that it's about to assign credit to like the right pieces of the neural network. And I will then say why that is very important for resilient societies also, to be able to learn what works and what doesn't work through data, in short. And also the key difference, and the reason why the sort of like bottom-up data-driven AI has, you know, so like beaten the other right now, the other like approach, in short, is because of data. We've talked about this. We're all, you know, connected, and we have smartphones, etc. And this is also pretty recent. It's about 10 years old. So that's the sort of gist. You've heard about some applications. So I guess you're, you know, all familiar with how so cell phone data in particular has been used in a number of cases to map and predict and model like human mobility, because it serves as like sensors like those phones. So, and this is based on machine learning. So this is a short comic strip that, you know, I did it. I think it's on our website. It's out to explain like machine learning, how you can predict mobility or population density through cell phone activity by having algorithms that learn. Like the relationship between digital signatures and population density, for instance. Then, so it can also be applied to criminality. So this is a project that we've been working on for a number of years, including with Telefonica in Colombia. So this is, we started in London, also with Telefonica, as a result of the Datathon of 2013. And basically, so this is, and this project in Colombia, I think is very interesting. It's called Ciudad Segura. Play on word, Ciudad. So it's sort of like, you know, crime hotspot detection and understanding why some places are more prone to high crime inequality. And the sort of like cell phone data is to try and characterize movement, diversity, and entropy of people in those places. Okay, so now I'm trying to talk quickly about and I'm looking at the time. Okay, so about climate resilience. So we, as Datapop and some research affiliates, we've also done specific work on climate change resilience. So I'm talking specifically about climate change resilience. So we published a paper, so almost 3 years ago, about that, you know, that topic. One of the, and you see the fine print here. So I'm not going to go. You know, don't worry. We're gonna. So we have like 5 recommendations for how big data can help climate change resilience. Monitoring hazards and, you know, stuff that were discussed earlier today. But I think one of the key points is to understand what is resilient. So it's basically the ability to adapt, to adjust, to be like agile, to learn, to react pretty quickly. So it's not to be robust, of course, and it's not only to sort of like bounce back to your previous position. It is really to adapt. So the idea of like a balloon, like an air balloon, is pretty, you know, it's pretty resilient, but there's a point where it breaks. If you keep poking it, at some point it breaks. But it can fall on the floor and it would bounce, boom, 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 and change its shape as opposed to a cup. So that, I think, is one of the key points of this paper, and something that is directly related to like whether and how data and algorithms can actually make societies resilient by making them more able to adjust, like almost in real time. So creative destruction, destructive creation. It's pretty hard to say. So you may have heard, if you take, again, a step back, or we stay in the realm of like resilience and climate change and so like shocks, you may have all heard this now a bit like tired analogy between data and the new oil and the new black, and so like, you know, big data, the new everything. But this is actually a cover of The Economist from 2017, so it's pretty new. But this analogy has been going on for almost 6 years. So so I did this cartoon in 2012 to sort of make fun a little bit of the analogy, or to say, are we really saying it's a good thing that data is the new oil? And then when you think about resilience, when you think about sustainable development and oil, well, you think of course, it's powered the industrial revolutions, but you can also think of oil spills. Okay, you can think of corruption, elite capture, all the bad things that oil does. So I think it's still interesting as an analogy because of to try and learn from the lessons of history and how data could be not fall in the same traps as oil, as the sort of the new resource of the economy. So these are some of the questions. Quickly, jobs. So are robots going to take our jobs? Basically, we know, and I like this cartoon by Canon, employees of the month, and then at some point it's Autotron, who's the employee of the month, every month. So will robots take our children's jobs? Which jobs are most at risk, etc.? I mean, there's a whole literature on that. Basically, if your job is very automatic, you're in trouble. I think one of the good things, I'm not convinced about universal basic income, because I think it will I think there are many disadvantages to such a system, which we can discuss. What I think is interesting, so these are my daughters, just a lot of what I do is about or for them, and I refer to them as sort of members of the data generation, as a sort of pun. Because they were born in 2010 at the very beginning of this era. So what I think is good is that all this movement is fostering, putting a premium on some things that make us very human. So collaboration, critical thinking, creativity, and that's that's good. But I think it will force us to upgrade a lot of our curriculum, how we teach kids. It's not just about coding, teaching them how to code. I think that will be part of it, but it's only a small part. So this is sort of about, of course, the dark side of big data. Facebook has become the sort of Godwin's point of big data. This book got a bit of traction, weapons of math destruction. Here, someone from MIT who works on algorithms and how facial recognition algorithms are better at recognizing white people or people with white skins. But it's not that the algorithm itself is racist. It's because the training set was very skewed towards white people. So the machine has not learned properly, and then it's not able to recognize people with darker skin colors. Okay, so now sort of brighter vision. So this is Sandy Pentland at MIT, whom some of you may know. Research, what am I, visiting scholar and fellow in his group. And he's one of the also co-founders of Datapop and of the Open Algorithms project, which I will come to. So one of his vision or arguments is how can we create human AI ecologies? So sort of it's not just about robots. It's thinking of a world where machines and humans would work together, be complementary, where data would sort of be the fuel of this macro system. So it's a pretty big vision, pretty ambitious vision. And what I said about the credit assignment function is key to that, because it's driven, this sort of world, this sort of human-machine ecology would be driven, powered, fueled by data to know what works and what doesn't work. And there would be indeed this credit assignment function that would say this policy works, this group of people works, and this is what he's been working on in corporations, organizations for a number of years, down to questions like, should you have open space in a company? Are open spaces good for productivity, or is it bad? Those kinds of things. So the key features is leveraging human-machine complementarities, thinking about new jobs, and you may have like more resilient, agile, like human-machine ecologies as a result. And here are some of the requirements. So you need good data. So I'm getting to like Opal. You also need some agreement on facts, on like what are data, like what are the goals. And that's pretty hard. I mean, there are very different cultural differences. And you need sufficient skills and trust. So these are some of the contemporary challenges to sort of like seeing this vision through. So some governments have, or companies have zero incentive for the status quo to change. I mean, if you look at this map of like democracy index around the world, it's just a proxy. Okay, it's all relative. But yes, so like the rationale are governments need better data to make better decisions. I mean, if you look, if you think of the list of 193 countries that have signed the SDGs, sometimes or often I want to ask them, are you really waiting for data, like better data, to do better stuff? I would say a good fraction does not. So there's a lack of capacities. It's also been discussed. And culture, and also data sources. So I'm coming to like Opal. Yeah. And then there's also, I think, segregation is a big problem. The fact that we cannot agree on facts, the fact that we cannot, like, we don't seem to be able to discuss, opposite views. And this is like like Facebook political discussions on the Facebook, and a lot of that is actually like increased or fostered by AI, by those like bubbles and echo chambers that some of those systems actually create. If you ever try to have a political discussion on Facebook about, I don't know, from gender-based violence to Catalonia to like the Israel-Palestinian conflict, you sort of know that it's impossible to have a sort of like civil discussion on Facebook in particular. So. But still, I mean, I think we have to remain hopeful. But one key message of this slide, it's a bit of a long slide, is that I think a lot of it has to happen in the analog world, and I think we have to think about how technology can help us, like interact as humans and really like in person. And I think it can, but there are really this risk, I think, of like sort of like dehumanization, where everything happens online, and then we're not really able to like pick up signals of how people react, etc., etc. Okay, so ending on Opal in like 5 minutes. Yeah, but I like to leave some time for questions. So the Open Algorithms project and concept is essentially, and it's been discussed, I mean, Pedro mentioned it, it's about inverting like the paradigm. So it's not about sending the data to people. It's about keeping the data. Think of cell phone data, and actually Telefonica is one of the two telecom companies that are part of the pilots in Colombia and Senegal with Orange Sonatel. So the data live with the people who have the strongest incentive for the data not to leak. And these are the telcos, because if their data leaks, then in terms of reputation, it's a terrible. Yeah, it would be terrible. So it's about sending the algorithms, those open algorithms, to the data, and that was initially the tagline. Now it's open algorithms for better decisions, and so I will show you in more detail how it works. But so we're starting with 2 pilots, as I mentioned, in Colombia and Senegal. So with Telefonica Colombia and Luca here, and Orange Sonatel and the Orange Group, there is, it's not just a technical solution, it's not just a technological platform, it is a technological platform, pretty advanced, very secure, that is being developed with, by MIT and Imperial College London to make sure that only the aggregated indicators are provided to the people using the platform, and in a very secured, privacy-preserving, etc. way. And there's also a governance track, which is like key to the system, which is about sort of like ethical body and also capacity-building activities. So the goal is really to scale, to make those like systems scalable, like systemic. We've all been in this world for a long time. We've all had MOUs and NDAs and contracts. At times, even we as Datapop, or we still have those contracts with telecom companies for specific projects. But I don't think this is the way it should be done in the future. I think there should be this. Yeah, like very clear system, but because it's also fairer, it's safer for everybody, and you can actually build businesses like around that if you have such a system in place. So this is the sort of like the ecology, the ecosystem of Opal. So the 5 founding partners and the sort of like main partners. So I have to say it's funded by the French Development Agency, and we're like fundraising for the second phase. And this is the last slide before taking some questions. So this is sort of like the vision of what I've been talking about, or a sketch of what this like human machine ecology for more resilient, fair societies would look like. So you can think of it so like every step and try to come up with an explanation or a rationale for why and how that would make societies more resilient. So I would say like the openness of the system is one reason that you can actually look into it. You can have people care about some sectors. You can create or incentivize use cases in different areas to be developed. And then of course there is the use of the data itself that can make so public decisions and business decisions like more efficient, also more transparent. They can be audited. If you're a public official and you say something, there will be like greater room for accountability, or people, if you have better data, would say, you keep on saying that tax cuts are going to do this, but the evidence seems to suggest strongly otherwise. As an example. So this is sort of like the Opal as I talk about it, it's like a key milestone and step towards this vision of a sort of like a fairer, more resilient, data-enabled model of society. Thank you.
Thank you, Emmanuel. I think it's a great vision. I think the very simple question is, when do you think this might happen? When will it be in place so we can have this new society?
Everything happens in steps. So the first step is, as you know, like having the system in place in both countries and show that and how it works. So that is going to happen by the end of the year. So it's like pretty short term. And then the long-term vision. I mean, I hope in my lifetime. So it's like the goal of my professional life. But honestly, it's so hard to tell that 10 years ago there wasn't, or 15 years ago there wasn't social media or Facebook, etc. But I would say that given the rate of change, I would say that in the next decade, so by let's say like the end of the SDGs, I think the world will be very, very different from what it is today. For instance, I think that, and I cannot wait for the time when there are only driverless cars at least in cities. And I think it would cut down the like pollution, traffic, like mortality in cities by, I don't know, but a pretty big percentage.
Yes. On the topic of a lot of the data we have today, they have a lot of biases. is it a big challenge making sure that these open algorithms, yeah, try to avoid those biases? How do we certify that the open algorithms, yeah, are pointed towards good things?
Okay, yeah, so it's a great question. I have to say that it's a great question, but it is a great question. And I'm happy I said that I was a demographer initially, so that's my, my background and something I'm personally always very attentive to. So the short answer is that those algorithms are indeed, I mean, people know about, biases, and we all realize that not everybody has a cell phone and that it's skewed towards, the richest people. If you think in terms of financial data, it's even worse. In Mexico, only 30% of people have a bank account, et cetera, et cetera. So if you do like machine learning, in some cases, it doesn't really matter because you just look at correlations. But if you want to have a finer understanding of the relationship, then you do need to account for the sample bias. So there are people, you can look at the work of Emilio Zagheni, for instance, or Ingmar Weber, who did the first papers that were trying to understand the structure of sample bias in Yahoo data. And actually, they worked in Barcelona on Yahoo data almost 10 years ago. So these algorithms, the teams that are going to develop the algorithms have to take that into account. So so they have census data, for instance, or they have other kinds of survey data, and they have to find to correct for the sample bias, especially when you want to apply this especially to have external validity in just a scientific term. Otherwise, if you just do a very crude machine learning model, it can be very good in your particular setting, but it will not generalize to other settings, and then you can make very, very bad decisions. You can send trucks of relief where it's the least needed, just because you don't understand the structure of your bias. Okay, thank you.